So again, this is Chapter 2, Lesson 1. So you want to solve each problem by isolating the variable, and we're going to use inverse operations. Solve by isolating the variable using inverse operations. We talked about inverse operations already this year. Inverse operations mean opposite operations. For instance, the inverse of adding is subtracting, and the inverse of multiplying is dividing. Inverse operations. Isolating, what does it mean to isolate something? Get it by itself. So we're going to get that variable by itself by doing the opposite operation. So we're going to start off with a couple easy ones, and then we'll progress towards harder ones, okay? We're going to also start off with just adding and subtracting. So let's do super easy. X plus 2 equals 6. I know that you can do this in your head. We all know the answer is 4. But again, that inverse operation would be a negative 2 on each side. If you're subtracting 2, it's the opposite of adding 2, which would then give you that 4. You want to think about checking your answers. How would you check your answer, Tate? You could do 4 plus 2. So if you substitute in your solution, then you could check your answer. 4 plus 2 equals 6. So we're good. What if we had 46 equals n plus 27? What makes that equation a little bit more challenging? Well, you don't just know it off the top of your head because it's bigger numbers, so that's a little bit more challenging. What's something else that's more challenging, Sam? It's backwards. And by that, I'm sure you mean that the variable's on the right-hand side instead of the left-hand side. If this is something, for whatever reason, this is something that usually throws people off. If it throws you off, it being over here on the right, then you could take everything that's over there on the right and move it to the left. And then what's on the left, move it over here to the right. And that's fine. You can do that for any equation. You can flip-flop the sides, okay? Now, I am not going to change it because I don't want to have to change every single equation that I work out. I'm going to be okay with the fact that it's written like this. But I want you to know that you can do that. It's fine, okay? Let's go back to where it was. There we go. All right, so to get rid of plus 27, because again, I'm isolating that variable. So to get rid of plus 27, I'm going to subtract 27. And I want to subtract carefully. I don't want to make a mistake in just subtracting. 46 minus 27 is 19. So you can either have 19 equals n, or you could write n equals 19. I usually like to write it so that my variable is listed first, even if in my equation my variable is on the right. It is not wrong if you write 19 equals n, though. Because remember, we can flip-flop them. It doesn't matter. 19 plus 27 is 46, so I could check my work also. All right. What if we had q minus 11 equals negative 9? So this one got more challenging because we have integers, negative numbers. Whenever we have negative numbers, we really have to be careful of what we're doing. So what's my inverse operation going to be? Adding what? Adding 11. So minus 11, positive plus 11, cancel out. Be very careful with your integer rules. Negative 9 plus 11 is 2. 2 minus 11 is negative 9. So again, be thinking about checking your work, making sure it makes sense. Sometimes you might have, instead of the variable and then the number, you might have the number and then the variable. Some people get confused by that. We want to isolate that a, meaning we want to get rid of minus 5. What's my inverse operation going to be? Plus 5, both sides. So we get a equals 26. Negative 5 plus 26 is 21. I hope that the 2 weeks that we spent on one-step equations and math review on the easy positive number problems, that this will then help you with doing these. We're kind of already reviewed a little bit this year. Let's do some with decimals. Do you think we're going to solve them any different? Nope, we're sure not. Decimal problems were worked out just the same way. What is my inverse operation to get g by itself? Plus 3.5. So those cancel. You get g. Remember, when you're adding decimals, make sure you line up your decimals, right? That's 14, carry your 1, 11.4. Boxing, it really does help. Let's do one more decimal, and then I want to do one fraction. How about so in this one I have decimals, I have negatives, and I have my variable on the right-hand side. So there's a lot of things that are a little challenging about this equation. What is going to be my inverse operation on both sides? Very good, minus 7.1. Showing your work really does help you kind of keep it straight in your head, what you need to do. Now, we know about integers. If they have the same sign, you should add the absolute values and keep the same sign. Okay, those are your integer rules. So they have the same sign, so we're going to add these two decimal numbers, and that would give me 9.6, and keep the same sign. A negative 2.5 minus 7.1 would be a negative 9.6. So be careful on your negatives, especially the decimals. All right, let's do one fraction problem, and then we'll move on to multiplying and dividing. If you had m plus 1/2 equals 5/8. What's my inverse operation? Minus 1/2. What do you know about adding and subtracting fractions? Common denominator. So what is my common denominator going to be in this problem? An 8. So 5/8 is fine. 1/2 would be what eighths? 4/8. So 5/8 minus 4/8 is 1/8. So this is combining a lot of different things that you know about math all into one. And you can imagine how it's going to be like once we get to 2-step, and then 3-step, and then 4-step. Okay? It's a lot of different skills that you have to remember. All right, let's move on to multiplying and dividing, solving by multiplying and dividing. Do we have any questions about these? All right, good, good, good. So this is negative 8 times n equals 64. To get rid of multiplying, we divide, and when you show division in algebra, it looks like a fraction. So to show that you're dividing by not just 8, but negative 8, we're going to make it look like a fraction. Sam, do you have a question? So multiplying by 8 and dividing by 8 cancel. Now, is that going to be a positive or negative 8? Because the signs are different. So when multiplying and dividing, same sign positive, different signs negative. What if we had negative 96 divided by negative 4c? What is my inverse operation, Calvin? Divide by negative 4, thank you. So I have c by itself. Two negatives make a positive. 4 goes into 96. How many times? 24 times. 4 goes into 9 twice, with 1 left over. 4 goes into 16 4 times. That's how you can do it in your head. I think the multiplying and dividing ones are easy because the rules for multiplying and dividing negative numbers is easier. What if we had m divided by 7 equals negative 12? What is my inverse operation? Multiply by 7. So m equals what? Negative 84. Negative 84. There you go. Here's one for all of you that say these are easy. Here's one that might be a little challenging then. So to solve for this, what's our inverse operation? To get k by itself, what's the inverse operation? Multiply by 4. Okay. So we need to do negative 17 over 2 times 4 over 1. That's what we're really doing here. Now, would our answer be positive or negative? Negative. Remember when you're multiplying fractions that you can use the shortcut of cross-reducing? So like 2 and 4 can both be divided by 2. It saves some time. So what's your answer to that? Negative 34. Negative 34. 17 times 2 is 34, not 38. That's okay. Just want to make sure we're all on the right track. Alright, we have one more type that I want to do before we move on. One more type. If you were multiplying your variable by a fraction, like in this problem here, to get rid of multiplying by a fraction, you would divide by it, which would be multiplying by the reciprocal. So again, you're going to multiply by the reciprocal. So the reciprocal of 2/3 is 3 over 2. So these cancel out. And 18 over 1 times 3 over 2 my advice would be to cross-reduce. Some people told me 27. Good job. You could do 18 times 3 and then over 2. Let's do one more of those and then we'll be done. One more. (36) equals 4/9 D. What am I going to multiply each side by? 9/4. bad if you need to write it out. It's okay. I know it takes a little bit longer, but please don't get things wrong because you don't want to take the time to work it out. So 4 and 36 can both be divided by 4. So you end up with 81. 4/9 of 81 is 36. All right, so you're going to have your assignment now. Again, some of them are going to seem super easy, but please make sure you slow down on the ones that have decimals or negatives, okay? You shouldn't, I don't want you to use a calculator. Don't use a calculator. Don't use a calculator. No.